everyone. Thank you for attending and welcome to the What's New in SecureAuth IdP to Start 2017 webcast. I'm Damon Tepe, Director of Product Marketing. I'll be joined today by Jeff Hickman, Solution Engineer here at SecureAuth. We've had some significant enhancements happen over the past 4 months or so, and our goal today is to talk you through those enhancements and how you can benefit from them. So we've had a couple dot releases and enhancements to other technologies since we last had a product webinar. As you can see on the slide, we've had both SecureAuth IdP 9.0.1 and Radius 2.2 release in late Q3 of last year, and SecureAuth IdP 9.0.2 late in December of 2016. Symbol to Accept, our newest addition to the multi-factor authentication method family, is not yet released, but coming very soon, so you're getting a sneak peek at that functionality. I'm going to cover IdP 9.0.1, Jeff will talk about Radius and IdP 9.0.2, and I'll come back to introduce Symbol to Accept and briefly introduce a new cloud-based offering before we open the lines for questions. So let's begin with IdP 9.0.1. The theme of this release is enabling the enterprise for more advanced security. And the major enhancements are around building integrations to vendors part of our Connected Security Alliance. Those integrations are with CyberArk for privilege account security, SailPoint for identity governance, and Exabeam for user behavior analytics. Another noteworthy enhancement was role-based access control. But let's first talk about why the Connected Security Alliance and the approach taken. This is the industry's first alliance focused on addressing the data breach problem. The purpose is to eliminate the white space between traditional siloed security solutions. The vendors work together to ensure interoperability and sharing of information. So this is not a paper or marketing alliance like most others in the industry. All solutions have real product-level integration, and we've co-created a reference architecture to accelerate and simplify implementations. The overall goal here is to better protect, detect, and remediate. So what benefits are gained with this integrated, holistic approach? As mentioned before, it's a truly integrated framework. So all solutions have passed rigorous interoperability testing to ensure integration and compatibility. The result is a reference architecture and documentation that can help you implement quickly and painlessly. Actionable intelligence. By providing multiple data sets to determine risk or evidence of attack, Alliance products can increase the chance of detecting a breach before it happens. So the 2016 Mandiant M-Trend report found that the average attacker has access to resources for 146 days before being discovered. And while that's better than the over 200 plus days in the past couple years, it's still over 4.5 months and simply too long. Traditional perimeter security is failing due in large part to the use of valid yet stolen user credentials, where attackers are walking in the front door, blending in with normal daily traffic. Network and endpoint security tools cannot identify or prevent this stolen credential problem. Alliance members leverage identity context to detect and protect against bad actors. That context is the foundation of identity. And examples could be location, where are access requests coming from known good or bad IP addresses, what access rights does each user have to sensitive resources? Is user behavior within the norm, or is a particular user acting oddly? We are all better together where the whole is greater than the sum of its parts. Defeating products one at a time is possible, but becomes nearly impossible when they are communicating together and acting as a cohesive whole. So, starting at the bottom of the on-screen picture, Exabeam correlates events and behaviors from a variety of sources to develop a dynamic risk score per user based on behavior analytics. Exabeam provides SecureAuth IdP with this risk score so we can better control the access of users exhibiting abnormal or risky behaviors. IdP also provides data back to Exabeam around user behavior, failed or denied login attempts, when requests were made, from what location those requests were made from, just to name a few. In SailPoint, Identity IQ correlates events from a variety of sources to determine a risk score around user access to critical or sensitive systems. And IDP uses this risk score to enforce stricter authentication policies for those users with access to high-value systems attackers most often seek to exploit. So it could be financial systems or systems housing customer or employee personal information. IDP protects access to CyberArk privileged account management functions as well, ensuring only authorized users can access privileged accounts, protecting the keys to the kingdom with minimal user disruption. And together, we improve security with greater visibility into more comprehensive data instead of siloed technology that doesn't work together or correlate findings. If you're interested in learning more, you can use the URL on the bottom of the screen or visit SecureAuth.com and search for Connected Security Alliance. So I've got one additional slide before I turn things over to Jeff. This enhancement is part of IDP 9.0.1 and it's role-based access control. This capability is often needed for larger IT teams, but can be valuable for smaller teams as well. By providing different access by different roles, organizations, for example, can delegate self-service functions like password resets, account unlocking to the help desk without fear they will knowingly or unknowingly alter security policies and authentication workflows. So with that, I will now turn things over to Jeff Hickman to talk about Radius Server and IDP 9.0.2 enhancements.
Thank you, Damon. So here at SecureAuth, we're really excited about our Radius 2.2 enhancements. They've allowed us to reach deeper in the authentication context around how we are authenticating users and what extra layers of security we can place when we're connecting from a VPN client or Wi-Fi connection or something along those lines. What we've done is we've enabled adaptive authentication for certain VPN clients at this point in time. We're leveraging Radius attributes that have been passed to us from VPN devices or other Radius integrations, specifically targeting Cisco, Citrix, NetScaler, Pulse Secure, and Palo Alto right now, to pass us the IP address of the connecting user. This allows us to do group filtering, country and IP address filtering, geo-velocity lookups, as well as IP reputation and threat checks around the actual client who's connecting to the VPN service. This is really powerful from the fact that most of our VPN integrations are kind of left open. They're by intention sitting on the edge of the web, allowing users to authenticate in. And with traditional MFA, we're seeing that there are ways that bad actors are getting around that, either through social engineering our end users or other methods that they're using. So adding an extra layer to security to be able to stop those people in their tracks is really powerful. So we're really excited to add adaptive authentication into the Radius story. In addition with that, we've also added on to our vendor-specific attributes support inside of our Radius server. So this really happens two ways. One, we can map attributes to return to the Radius client from the IDP, meaning that if you have a profile field, such as maybe a group list or a specific unique identifier that your Radius integration requires, we can pass that back to the Radius server from the Radius server, back to the Radius client so that it can be leveraged by that integration. And then additionally, we can also pull information that's sent to us in the vendor-specific attributes from that Radius client. This allows you to, achieve better feature compatibility with certain Radius clients. In fact, we'll talk about NetMotion support a little bit later on here, which leverages this specific vendor-specific attributes that we're using to enable its functionalities to continue to work. In addition to those attributes and the adaptive authentication, we've also added the ability for you to edit and customize the verbiage that your end users see when authenticating to the Radius server. This allows you to brand, inform, and educate your end users with custom messages. It really helps you target and hone what you're doing from an authentication standpoint and maybe clean up some of the language that works better for your end user base. As mentioned earlier, NetMotion support was added to the Radius 2.2 server. This is leveraging those vendor-specific attributes. And NetMotion, the reason why we wanted to highlight this is it is a fairly unique mobile VPN solution. The reason why it's unique is because it allows you to jump from WAN internet source to WAN internet source, such as cellular data to maybe a public Wi-Fi spot, back to cellular data, and all without losing session or having to reconnect. It's widely used in the law enforcement field, or public utilities, or even insurance companies. Anyone with a large mobile workforce who needs to always be connected has a lot of adoption out there for that. And it keeps the session state between each authentication attempt and each VPN reconnection. So it's really seamless for your end users to use, where they're only authenticating at one point when they turn on their device and they initially connect it. So we're really excited about those enhancements to the Radius server. They do allow us to increase the security around Radius authentication and allow us to do some deeper analytics around how our users are leveraging connections from the Radius server. Moving on to SecureAuth IdP 9.0.2, we're really excited about these features as well, specifically our phone number fraud prevention features we've added. We've also added some noteworthy enhancements around device recognition and second factor persistence, which I'll get to after the phone number fraud prevention items. But we're really excited about this strictly because most of us have probably caught that NIST came out recently, and in a draft article they stated that they will be depreciating SMS as a second factor method, which kind of alarmed us. And the reason why is that there's great amount of adoption around SMS as a second factor from our end user perspective. Most end users are already familiar with getting text for second factor from things like their bank, or even LinkedIn or Amazon Web Services, or whatever they're using. They're used to that, and it's something that's comfortable, and they've come to expect it. So with SMS on the docket to be depreciated, it kind of worried a lot of users and a lot of information security people out there. Well, what are we going to do? Well, what's the alternative? And SecureAuth said, well, why does there have to be an alternative? Why can't we strengthen what we're doing around SMS delivery of OTP as well as phone call delivery of OTP? So we went to the dev team and we said, hey, what can we do, guys? And they said, well, we got all this information, this contextual information. Why don't we leverage it? So our the first place that we're leveraging this information is around the ported status of a number. We can actually retrieve if a number has been recently ported by the carrier. It's actually reported directly to us from the carrier, and it will allow us to block the ability to use that number for text or voice call-based OTP messages if we see that it's been recently ported. When the user goes to select that method, it will actually inform them that, hey, this method is not available at this time. Please select another second factor method. So in this instance, the user would have to use something like maybe email or mobile app integration to actually second factor. And once they've done that, they can then be presented with a screen that allows them to approve the carrier change, meaning approve the ported number, or even delete the number from the data store because they didn't approve that port. Or ignore and suppress the message to be prompted next time that they log in. This is really powerful against preventing against one attack that we have seen recently climbing, which is the phone card SIM swap fraud. What that allows a bad actor to do is basically socially engineer their way into your phone provider, such as T-Mobile or Verizon or whoever it is, and basically get your number from your device ported to their number. Usually they port this to maybe like a burner phone or a voice over IP phone. And once they've done that, any text message request or phone call sent to your phone goes to their device instead because they've ported it now. So it is a possible way for them to circumnavigate standard SMS or voice call authentication, but with this phone number, ported numbers blocking check here, it really strengthens that use case. In addition with that, we're also allowing our customers to block carrier networks. So again, things like Verizon or AT&T, T-Mobile, all those carriers out there, you can actually selectively block those from being able to receive OTP messages from SecureAuth. And in fact, you can even block it by geographic region. So you can block out all the carriers who are located in China if you don't do business there and you don't want your users using phones that are registered with a Chinese carrier. We'll automatically detect and update the list of carriers as that list grows or shrinks depending on what happens out there in the wider world from a phone carrier perspective. And it's a really great way to kind of lower the threshold from an attack surface perspective of what's actually available to be attacked at. In combination with that, we also wanted to increase the control that administrators had over blocking classes of phone numbers, specifically around virtual voice over IP phone numbers, as well as toll-free or even premium rate phone numbers as well. Really, in a business use case, there's not a lot of reason to allow people to use toll-free numbers or premium rate phone numbers to receive an SMS or a voice call to. So now as administrators, you can choose to block those services from receiving OTP. In addition, we've kind of seen an uptick, in one of NIST's main recommendations was around the virtual voice over IP type usage of receiving OTP and SMS. So we wanted to make sure that we were allowing administrators to block that across the board so that we will not support voice over IP devices once that feature has been enabled. In kind of combination with those features, as well as hitting some of our other multi-factor options already in the product, we've enabled OTP Spam Prevention. What this really is aimed to do is throttle the amount of OTP requests, or just second factor requests in general, that are sent to an end user. What this will kind of help prevent is the brute force attack method that some attackers use, specifically around things like push to accept, where the user's device is spammed with a bunch of request messages to log in. And let's face it, a lot of our users don't really pay attention to why that's happening. So maybe the first couple times they hit deny because it's out of the ordinary, but they get tired of getting the message, so then they hit accept, and then your bad actor's in. So now what we do is we can allow you to configure how many OTP messages or how many two-factor methods can be sent within a certain time period. For example, the default is 5 messages in 30 minutes. So after the user has hit that cap, they will have to wait, however long it is until those attempts fall off. Once they fall off, the user can then again try to do a second factor method to gain access. It really helps kind of navigate some of the socially engineering abuse that's happening around bypassing two-factor by throttling and making it not worth the attacker's time, because they're having to spend hours trying to get in rather than previously where it could have been a few minutes because they could spam so many attempts. As mentioned before, we did have some noteworthy enhancements in 902, specifically around our device recognition and the scoring logic that's used. We're adapting to new browser technology around font detection and other plugin and attribute detection that the browsers return to us. This is something that's going to be constantly evolving for SecureAuth as browsers change the amount of information that websites are able to access, and as new hooks become available for us to leverage to uniquely identify devices. You should expect to see device recognition updates on most of these kind of what's new webinars because it's a constantly adapting and changing process around how we uniquely identify devices. In combination with that, we also enhance the second factor persistence. What this allows us to do is remember the user's last choice for second factor. So for example, if they've selected sending a login request to their mobile device the last time they came through, it will have that radio button pre-filled for them on their selection, and all they have to do is hit submit. This is stored client-side on the browser, so if the user clears their browser session or their cookies, more importantly, they won't have that kind of persistence around it. So it doesn't require us to write back to the data store. It's more of a usability or user enhancement feature that we are tackling here to make it really nice for our end users, not having to have some extra clicks in the process. And with that, I'm going to hand it back over to Damon to speak about our new symbol to accept feature.
Great. Thanks, Jeff. Appreciate that for reviewing Radius and IDP 9.2. We'll now turn our attention to this new multi-factor authentication method called symbol to accept. And to understand why we developed symbol to accept, a new and more secure multi-factor authentication method, we need to do a quick review of how push to accept works and its vulnerabilities. So push to accept is a commonly used and popular multi-factor authentication method, growing in popularity because it provides a very fast and convenient second factor authentication using a smartphone app. So the typical push to accept workflow kind of goes like this. User attempts to authenticate to a protected resource, could be a VPN. The VPN is protected by MFA software. The user enters their ID and password into the prompt. The user is then informed they need to take action for the logon to continue. Authentication software sends a push notification to the phone where the app is installed. The user opens the push notification, opens the app, and the user is typically presented with two options, accept and deny. When the user presses accept, phone notifies the VPN, the user accepted, and access is granted. So pretty easy and simple, right? The problem with push to accept is that it's very susceptible to phishing. So users just press accept when prompted to do so, even if not in an authentication process. And so to give an example, there's a link on the screen that goes to a video from the DEF CON conference where a hacker describes 6 out of 6, or 100% of his attempts using this, users accepted when not authenticating, which means our hacker with stolen credentials easily gained access to organizational resources by way of user error and circumventing this popular multi-factor authentication method. And, you know, it kind of works like this. You know, attacker obtains username and password for user A at Acme Corporation. You know, attacker browses to that web resource, could be the VPN, uses those compromised credentials to begin the login process. Strong authentication sends that push notification asking for an accept or deny from the actual user, and user A kind of robotically accepts, even though they're, again, not in that authentication process, and attacker gains access. And we've all kind of been there, right? You know, been busy, you know, trying to respond to an important email, or we're in the middle of thinking through a problem, and we really just want to get this thing off of our phone, right? Why is this notification on our phone? And so that temptation to hit accept when not authenticating causes a serious security concern with this method. And the fact that an attacker successfully bypasses this method 6 out of 6 times leads us to create a better, more secure method. And so our answer to this problem is simple to accept. The objective is to prevent the user from just pressing accept, particularly for fraudulent requests. And so with our simple to accept, the idea is to present the user with an image on the web interface, you know, the PC or Mac screen, and the user must match that image on the mobile app. So instead of just kind of auto-pressing accept or deny, the user must select an image that matches what they see on their PC to approve the transaction. So from a human perspective, this is very effective because the user has not been programmed to just press accept. Instead, they must know what to pick. They must think before hitting a button. And it's very unlikely that a user would start guessing an image to select if they receive an unsolicited push notification, as detailed kind of in the previous push to accept scenario. So although not related to SecureAuth IdP, I wanted to make you aware of a new cloud-based identity as a service solution we launched in early Q4 of last year called SecureAuth Cloud Access. And we brought this solution to market because we saw a growing number of organizations seeking cloud-based solutions. Maybe you have a CIO preference for a cloud-forward strategy. While Cloud Access and IdP are not the same product, some customers are deploying a hybrid solution, leveraging capabilities of both products to help satisfy a cloud-first mandate and or reduce administration with identity as a service. If you're looking to supplement your SecureAuth IdP deployment by offering users the convenience of single sign-on and reducing the number of credentials employees need to remember, Cloud Access has one of the industry's largest app libraries, supporting over 8,000 applications. So maybe you're seeking an all cloud-based access control and authentication solution to replace IdP and other solutions. Cloud Access has both multi-factor and adaptive authentication capabilities that improve security and only require a multi-factor authentication step if risk is present, further enhancing the user experience. And because Cloud Access is cloud-based, it's easy to deploy, hours and not weeks and months, and the administrative interface simplifies the time and resources needed to manage access, particularly for SaaS-based applications. So if you have a need, I encourage you to trial it for free at the URL on the screen, or at least read more about how it might be able to solve your problems. We have brief demo vignettes, roughly 2 to 4 minutes apiece, to quickly give you a feel for how the service works. And with that, I'd like to thank you for your time today, and I hope you have a great rest of your day. Thank you.